Friends. Hope you all are doing good. We are towards the end of this first chapter. Can a computer have a mind? So, we have been reading a lot of things like how much we have advanced in developing machines or devices or computers, but does these devices have a mind, a consciousness? So in this first chapter, we had been discussing about uh, having a mind or consciousness in this uh, cleverly developed devices. We are towards the end of this chapter. Let's finish this chapter, and in my next video, we can discuss about whatever we had been reading in this uh, 37 pages of this chapter. Suppose it is true that teleportation does actually work, in the sense that the traveler's own awareness is actually reawakened in the copy of himself on the distant planet, assuming that this question has genuine meaning. What would happen if the original copy of the traveler were not destroyed, as the rule of this game demand? Would his awareness be in two places at once? Try to imagine your response being told the following. Oh dear, so the drug we gave you before placing you in the teleporter has worn off prematurely, has it? That is a little unfortunate, but no matter. Anyway, you will be pleased to hear that the other you, the actual you, that is, has now arrived safely on Venus, so we can dispose of you here. Of the redundant copy here. It will, of course, be quite painless. The situation has an air of paradox about it. Is there anything in the laws of physics which could render teleportation in principle impossible? Perhaps, on the other hand, there is consciousness by such means, but that the copying process involved would inevitably destroy the original? Might it then be that the preserving of two viable copies is what is impossible in principle? I believe that despite the outlandish nature of these considerations, there is perhaps something of significance concerning the physical nature of consciousness and individuality to be gained from them. I believe that they provide one pointer indicating a certain essential role for quantum mechanics in the understanding of mental phenomenon. But I'm leaping ahead. It will be necessary to return to these matters after we have examined the structure of quantum theory in chapter 6. Let us see how the point of view of a strong AI relates to the teleportation question. We shall suppose that somewhere between the two planets is a relay station where the information is temporarily sorted before being retransmitted to its final destination. For convenience, the information is not stored in human form but in some magnetic or electronic device. Would the traveler's awareness be present in association with this device? The supporters of strong AI would have us believe that this must be so. After all, they say any question that we might choose to put to the traveler could in principle be answered by the device by merely having a simulation set up for the appropriate activity of his brain. The device would contain all the necessary information, and the rest would just be a matter of computation. Since the device would reply to questions exactly as though it were the traveler, then Turing test, it would be the traveler. This all comes back to the strong AI contention that the actual hardware is not important with regard to mental phenomena. This contention seems to be, to me, to be unjustified. It is based on the presumption that the brain or the mind is indeed a digital computer. It assumes that no specific physical phenomena are being called upon when one thinks that might demand the particular physical, this biological, chemical structure that brains actually have. No doubt it would be argued from the strong AI point of view that the only assumption that is really being made is that the effects of any specific physical phenomena which need to be called upon can always be accurately modeled by digital calculations. I feel fairly sure that most physicists would argue that such an assumption is actually a very natural one to make on the basis of our present physical surroundings. I shall be presenting the reasons for my own contrary view in later chapters, where I shall also need to lead up to why I believe that there is even any appreciable assumption be made. But just for the moment, let us accept this commonly held view that all the relevant physics can always be modeled by digital calculations. Then the only real assumption apart from questions of time and calculation space is the operational one. That if something acts entirely like a consciously aware entity, then one must also maintain that it feels itself to be that entity. The strong AI view holds that, being just a hardware question, any physics actually being called upon in the workings of the brain can necessarily be simulated by the introduction of appropriate converting software. If we accept the operational viewpoint, then the question rests on the equivalence of universal Turing machines and on the fact that any algorithm can indeed be affected by such a machine, together with the presumption that the brain acts according to some kind of algorithmic action. It is time for me to be more explicit about these intriguing and important concepts. So, with this, the first chapter of this book ends, that is, can a computer have a mind? In the next chapter, Sir Roger Penrose discusses about algorithms and Turing machines. In the introduction and the very beginning, we had been discussing about Turing test, then artificial intelligence devices, and also strong AI and Searle's Chinese room. So in my next video, we'll be reading about this algorithms and Turing machines. So this much for today. Bye bye. See you in the next video.